Morning to you all. My name is Idhor and I am here to present my operating system project, which is a distributed file system that I, along with my two teammates Chakkachini Krishna and Mulli Manohar Kumar, had made for the past 30 days. So the goal of our project was to build a distributed file system that ensures the data availability, consistency, as well as the fault tolerance across multiple nodes, as well as it should also handle node failures gracefully while maintaining the data reliability. To make this project, we took some inspiration from the enterprise level systems that is already existing in the current world, such as the Hadoop HDFS Google file system, as it uses a master worker architecture. Morning to all. We have used to make our whole project is that for the code language we choose Python 3 as due to its robust networking and logical capabilities. For the cross-node communication, we used XML RPC as it is a very good built-in Python libraries which is good for handling cross-network remote procedure calls. For storing all the metadata of all the files, we used SQLite 3 as it is a very lightweight and it also creates a persistent relational database for our master nodes. For the frontend and GUI, we use Streamlit, and for the security, we used HashSlip library as it has a SHA-256 cryptographic hashing. For the analysis and visualization part, we used certain libraries of Python such as Pandas and Altair for our real-time storage and time series graph. Technology is the main dashboard of our project. Here you can see since our master node is not connected to our dashboard, so here you can see the status is currently offline. So to connect our master node to our dashboard, here we have to click on the connect and see the status is online, which shows that our master node is connected to our dashboard. Here on the live cluster health, we can see that the node A and node B is currently showing offline. Since our both the nodes are not connected to our master nodes, that's why the both status is offline. Here in our navigation panel, we have the two options, main dashboard and storage analysis. In our storage analysis, here we don't have any data since in our system, not a single file is present. That's why no graph or no data are currently being shown. So this is now the main. You all got a brief description about our project. So let's upload a file into our system. Let's take a random file and just click on the upload. Here we can see a message is coming which shows that both the data nodes are currently unavailable. So this message is coming since none of our nodes are connected to our master node. That's why if we just upload our file, then the metadata of our file can't be saved in any of our nodes and the system will fail. So to prevent this, first we have to make at least one node active. To do that, we have to go to the file and open a terminal, and here we have to write a line. While running this python data node.py 5001, this 5001 is basically the node 1, and by running this line, the data node 1 is currently running, and if you can see here the data node 1 is currently active. Same like this, if you want to make our data node be active, we have to open another terminal and write the same line but with code 5002. And if you will just execute this line, here we can see the data node B is also active. So now if we just upload a file and click on upload, here you can see the file is successfully uploaded in our system. Here we have three options: preview, download and delete. So if we click on the preview, we can get the live preview of our image that we have now uploaded. This is our download options. If we click on the download, it will download the file from our node, and to get that downloaded file, here we have a download folder and see our file is successfully downloaded. We just click on that, we can get the file. Here you can see one chunks across one version is written. One chunk means in our system we used a loop, and the work of this loop is that when we will insert a file into our system, the loop will uh, divide the file into many chunks, and each chunks have a size of 2 MB. So for example, if the file is less than 2 MB, only one chunk will be saved into our system, and the master node will save one copy of our chunk to the node 1 and one copy of the chunk to our node 2. Here you can see the file has two chunks and two copies in both of the nodes. This is a feature which is known as the load balancer. For example, take a situation that uh, first of all, let's delete this file. See, the file is completely deleted, and if you just go to the nodes, see, nothing is here, which shows that the file is completely deleted from our node as well as from our database. So let's again upload a file, and now we will test a situation in which only one node is currently running. So let's stop this node. It will take some time, and see, the node A is showing offline and the node B is currently active. So in this situation, if we will upload a file to our system, the copy and all the data of this file will only be stored to the node B, and if you go to the node A, nothing is stored. This is because only one node is currently connected to our master node. So in this case, if you will download, see, the download is currently successful, and we'll go to download. Here you can see the file which we have downloaded now. Now we show a situation where we uploaded a file as well as downloaded a file using one node. But this is a very critical situation, as just think of a situation where both the nodes are currently offline, and in that situation if you will just download a file, then we can't get any file back to us, as both the nodes are currently offline and the master node can't fetch any metadata from the nodes. So if you will just demonstrate this situation, let's shut down our node 2. It will just take some time to refresh. See, then both the nodes are currently offline. In this situation, if you will click on the download button, see, a message is showing cluster offline, download aborted. This shows that both our nodes are currently offline and the master node can't fetch back the files from our database. So this is a very critical situation, as we have now uploaded a file to only one node, and if that particular nodes get shut down due to any reason, then we can't get our file back. So in that situation, we will just make our node active. Here you can see both the nodes are active, and if you just remember, at that time, since only one node was working, so all the chunks were stored into one node only. But now both the nodes are working. So when we will go back to our nodes, here we can see this file was already uploaded when I clicked on this upload button. But now since I have made the second node active, here we can see if you will just go to a second node, the copy of the file is also present in the second node as well as the first node. This is a feature of background load balancer, as if there is a situation where only one node is working and at that time if you just upload a file, then all the chunks will be stored to the active nodes only. But when we will just make the second node active, then our system will detect the activeness of that second node and silently copy all the chunks present in our active node to the new active node. And after that, both our node will have one copy of the chunks. Now we saw a situation. Now think of a situation where we uploaded a file to our system, and as usual our system will divide that file into several chunks and save each of the chunks to both the nodes. But in between this process, if due to any reason one chunk in any of the node get corrupted, then can we get our file back to us? Let's see and demonstrate this. So to perform that, let's first of all upload a file. Click on upload and it will upload our file to our system. And as we all know, since it's less than 2 MB, so only one chunk will be saved here, and one chunk will be saved to the node 1 and one chunk will be saved to the node 2. So due to any reason during this process, if let's suppose if this file gets corrupted, so to perform that, let's corrupt this file. Just write any random thing, just corrupt this file and save. So now we know that this chunk is corrupted, but the chunk in the node 2 is not corrupted and is completely fine. So in this situation, if we will download the file from our system, the file will be successfully downloaded. And if we just check here, see the file is downloaded here. So you might have thought that this node or this chunk is corrupted, but this chunk is not corrupted. But rather than that, we can get our file back. This is because our system has a fault tolerance features in which while if we just download this file, then our system will detect the corrupted file and will while downloading the file back, our system will replace that corrupted chunk with the protected chunk from another node which is not corrupted and give our file back. Due to this reason, even after corrupting this chunk, we can get our file back by using this chunk. So this is a feature of fault tolerance in our system. Now you all have seen about the fault tolerance features of our project. So while performing that, you all have seen here v1 is written. What is this v1? This v1 represents that the file is of version 1. So our system is having a version control system in which we can track as well as download the earlier or latest version of any file simultaneously. So to demonstrate that, let's upload a file to our system and click on upload. Then our file is successfully uploaded to our system. So now let's think of a situation that in day 2 I did some changes in this test.txt file, and then I again uploaded that file, latest file, into our system. So what will happen? Let's see. So let's modify this file and do some changes for day 2 and save this file. So this is the latest file that we are having. So if we will upload the latest file and click on upload, you all can see that v2 is showing. What does v2 represent? This v2 represent that this file is of version 2, which means that our system has automatically detected that we have uploaded this file two times. One is having some changes earlier, so our system representing that as a v1, and again when we are uploading this file in our system, our system scans all the contents of the file and saw that certain changes are present. So our system termed that changes as a v1, and here we can see we have the version 1 of our text file as well as the version 2 of our text file. So you know that in our version 1 we have all the data of our day 1. So if you will download the version 1 of this text.txt, so the version 1 of our text.txt gets downloaded, and here in the download you can see only the day 1 content is present. Now you all have seen, if you want to get all the data of the day 2, then we can just choose here the version 2, as we know that the version 2 has all the data of the day 1 as well as the day 2, which is the latest version of this file. So if we just choose a v2 and download, then the version 2 of our text file gets downloaded, and here we see that we get the version 2 of our text file, which contains a day 1 as well as day 2, but the version 1 of our text file is only having the day 1 data. This is a very nice feature where we can track all the previous as well as the latest version of our file, and we can check that what modification we have made, or we can just get the previous file and do some changes in our file. There are certain future scopes in our project that we can add later on, such as parallel transfer feature or multi-threading, where we can use the thread pool executor library of the Python to fetch the chunks 1 from the node A and chunk 2 from node B simultaneously, which can drastically increase the network speed. As well as we can use the end-to-end encryption features by integrating the cryptography library to encrypt the entire byte stream before chunking the file. We can also integrate the feature of storage duplication by optimizing the hard drive space by checking if the chunks SHA-256 has already existed in the database before uploading. By this, we can map the duplicate chunks rather than retransmitting them over the network. So that's it for the project. Thank you.